Hey Finxters! Now today's discussion is about a very important Google interview question. Now this question has been commonly reported by many programmers across the globe who said that they came across this question in their interview. So there is a high chance that you may also come across this question in your interview. Now this question asks you to find the k closest numbers in a sorted array. To further understand this question, let us have a look at a few examples. Rather, before moving on to the examples, let us have a look at the problem formulation and then we will move on to the examples to understand the question better. So what this question asks you to do is that you will be given an array that consists of integers. You will also be given a value or an integer value x and another value k. So what is this x and k? X is that integer to which you have to find k closest integers in the given array. Now remember that the given array is already sorted for you in ascending order. So are you confused? Maybe yes. Hence, let's move on to a few examples and let's try to understand the question well. Once you understand the question, only then can you solve it properly. So let's have a look at a few examples. Now let's have a look at the first example. Suppose the input array is as shown on the screen, 8, which consists of elements 8, 10, 12, 15, 18 and 20. Now the integer value that is given to you is x, which is 15 in this case. And you have to find 4 closest value to 15 in the given array. Now in this case, 15 is already present in the array, so it will also be a part of the output. Now if you have a close look, you'll find that the values 10, 12, 15 itself and 18 are the values which are closest to 15. So that is going to be your output. Now the next question is, what if 15 was not a part of the input array? So that brings us to the next example. Now suppose the input array consists of integers 4, 6, 8 and 9. And now the integer to which you have to find k closest elements is 7. So is 7 a part of this given input array? No, it isn't. So what do you have to do here? You have to find 3 such values which are closest to 7. Now if you have a close look, you'll find that 6, 8 and 9 are the closest values to 7. So that will be your output. Now there might be another question that comes up in your mind. What if I have such values in my array or in the given array such that they are at equal distances of the given integer? For example, let's look at example number 3. So this is the input array, which consists of integers 2, 3, 5, 6 and 7. Now the given integer to which you have to find k closest values or k closest numbers is 4. Now here you can see that 4 is not a part of the input array, but that's not the only problem we have. If you look closely, you'll find that 3 and 5 are at equal distances to 4. Now what do you do in this case? In this case, you have to consider the number which is lesser than 4 as your output. So I hope you get the point. Since 3 is less than 4, that will be your output. And here you have been given that you have to find only one closest neighbor to 4. If this was 2, then we would not have any problem as the output would have been 3 and 5. But you only have to find one closest integer, which is 3 in this case, as 3 is less than 4. Now let's also have a look at an edge case wherein you have been given an integer array which only has one value. For example, in this case you have been given an input array which only has the value 5 and you have to find one number which is closest to the value 4. So in this case it is pretty simple. You simply have to print the value that is present in the array. Now you might be wondering, what if the value was 25 instead of being 5? Then your output would have also been 25 because that is the only value which is present in the given input array. Now I hope that the question is clear, and with this let us dive into the solutions or the approaches that we can follow in our interview. Now, the best way to approach any question is to think what is the interviewer trying to test when he or she presented me this question. And as soon as you do that, you'll find that the interviewer is trying to check whether you can play around with the binary search algorithm. Yes, this question revolves around the binary search algorithm, and that is exactly what the interviewer is trying to test. Of course, things like time complexity, space complexity do matter, but you have to be able to solve the question first before thinking of the other parameters. Hence, your first task is to solve the question in the easiest way possible, and then you can make improvements upon it. I hope that makes sense. So let's go ahead and try to solve this question in the easiest way possible. And then we will think how we can make improvements upon our code to reach the optimal solution. So the most straightforward solution to this problem is to break it down in two parts. In the first part, you can use the binary search algorithm to find the insertion point. Now, what's an insertion point? The insertion point is the point where the integer x can be placed or inserted within the sorted list. Now, why do I say a list? Because you can also consider this array as a list in Python. Thus, the elements that are before this insertion point are going to be smaller than the given integer, while the elements that are after the insertion point are going to be larger than the given integer. Once you are done with this, then you can move on to the next part of your algorithm, wherein you can compare the elements around this insertion point that you found, and then you can find the k closest numbers around this point. So to understand how we are going to do this, let's have a look at an example that will definitely help us with our algorithm. Now consider that the given array has the following integers. As you can see on the screen, the values are 8, 10, 12, 15, 18, and 20. The value of x around which you have to find the k closest numbers is 15. So x is 15. And the value of k given to you is 4. That is, you have to find 4 numbers in the given array or in the given list which are equal to or closest to 15. Now, as we discussed earlier, the output in this case should be 10, 12, 15 itself, and 18. As I mentioned, let's divide our program in two parts. In the first part, let's deal with the insertion point, which happens to be 15 in this case. But how do we find that? To do that, you will need two pointers. In this case, we considered the pointers to be start and end. Start points to the first index of the array, which is 0, and it will be 0 in all cases, while end points to the last index of the given array. This means if the length of this array is 6, then end will point at 5. Since indexing begins at 0, so the last index will be 5 when the length of the array is 6. Alright, we now have our start and end pointers. Let's go ahead and find the insertion point. In order to do that, we need to iterate over the elements in the array until we find the insertion point. So how long do we iterate? We have to iterate until start is less than or equal to end. Now, initially, is start less than or equal to end? Yes, it is, because start is now 0 and end is 5. So at this point, we have to find the mid value. If you remember, we did something very similar to this in binary search algorithm as well. So that is exactly what we are going to do here. To do that, we will be using the formula that just appeared on the screen. Now, as soon as we feed in the values in this formula, we'll find that the mid index is given by 2, which stores the value 12. So I hope this is clear. Let me show that again. 12 becomes our mid value in the first iteration and it is marked by the second index. Now that we have our mid index, it is time to check if the value at the mid index is less than 15 or is it greater than 15. As you can see, 12, which is the value at the mid index, is less than 15. Hence, we will now shift the start pointer towards the right. And what will it point now? It will now point to the index which is given by mid plus 1. That is the index which is just beside the mid index towards the right. So what is the index which is just beside the mid index towards the right in this case? It is 3. So now the start pointer will point to 3. It's now time to move on to the next iteration and we again check, is start less than or equal to end? Yes, it is, because start is 3, which is less than 5. Hence, we repeat our operation once again. We find the mid value, and in this case, when we feed in the values in our formula, we'll find that mid appears to be 4 and it stores the value 80. Once again, we are going to check, is 18 less than 15 or is 18 greater than 15? Now we find that 18 is greater than 15. Previously, the value at the mid index was less than the value of x. But now the value at the mid index, which is 18, is greater than the value of x, which is 15. So instead of shifting the start pointer, we will now shift the end pointer. And where do we shift it? We are going to shift it towards the left such that the end pointer now points at the index which is just beside the mid index towards the left. That is, the mid index now is 4. So the index which is just beside 4 towards the left is 3. So end will now point to the third index. Okay, it's now time to move on to the next iteration and we check, is start less than or equal to end? And in this case, we find that start is equal to end. So we move inside the loop and then we again check the value of the mid index. Now in this case, since start and end are both pointing towards 15, this means 15 is going to be our mid index. You can also check that out if you put the values in the formula, but I hope you are getting the point. Since end and start point at the same index, the value of mid will also be 15. Let's have a look at that in the formula as well. Now, if you look at this, end minus start is going to be 0. So this section of the formula is going to be 0. Hence, mid will equal to start. So mid is also 15. Now, our next task was to check if the value at the mid index is less than or greater than 15. But now we find that the value at the mid index is equal to x, which is 15. And as soon as that happens, we will simply return the index of 15. So what's the index of 15? It's 3. So we have successfully found our insertion point. This brings us to the next phase of our algorithm. Now we have to find k closest integers, that is 4 numbers that are closest to our insertion point, which is 15 in this case. Hence, let's try to find that. As we know, the value of k given to us is 4. And now we are again going to use 2 pointers. And in this case, I'm going to call these pointers LHS and RHS, such that RHS will point to the value that was returned by our previous function that is the index of the insertion point, which happens to be 3 in this case, and LHS will point to the index just before RHS, that is 2 in this case. Okay, we now have the value of k and our pointers, rather I should say our initial pointers, and now it's time to find the k closest values. To do that, we will again use a while loop such that we will keep on iterating until and unless the value of k is greater than 0. So let's check, is k greater than 0? Yes, it is. It is 4. So 4 is greater than 0. So we move inside the while loop. And now we have to check 3 conditions. The first condition being LHS is less than 0. So we are going to check, is LHS less than 0? Or we will be checking, is RHS less than the length of the given array, and is the absolute value returned after subtracting x from the value at the LHS index greater than the absolute value returned when we subtract 15 from the value at the RHS index. So let's go step by step and let's have a look what happens in each iteration. Now, before proceeding further, let's have a look what happens when these conditions are either true or false. When this condition is true, then we are going to shift the RHS pointer towards the right by 1 place. While if this is false, then we are going to shift our LHS pointer towards the left by 1. Okay, I know this can be confusing. So let's have a look at every iteration. So in the first iteration, is LHS less than 0? No, it isn't. Now, is RHS less than the length of the array? Yes, it is, because RHS is 3 and the length of the array is 6. We also have to check if the value returned or the absolute value returned when we subtract x, which is 15, from the value at the LHS index, which is 12 in this case. So 12 minus 15 is minus 3. Since we are finding the absolute value, so it's going to be 3. So is 3 greater than, and then again we have to compute the value at the RHS index minus x. Now the value at the RHS index is 15, and 15 minus 15 is 0. So is 3 greater than 0? Yes, it is. So we can safely say that our condition evaluates to true. Hence, what are we going to do? We are simply going to shift the RHS pointer towards the right by 1 position. Let's have a look at that. And there we go. Now the RHS pointer points towards the 4th index. Once this is done, we reduce the value of k by 1. So now the value of k is 3. We now move on to the next iteration. And once again we check, is LHS less than 0? No, it isn't. But we also have to check for the other conditions. If that is false, then we can say that we can shift LHS towards the left by 1 position. So let's check that. Is RHS, which is 4, less than the length of the array? Okay, it is 4 and it is less than the length of the array, which is 6. And now the next condition. Let's subtract the value at the LHS index, which is 12, from x. Now x is 15, so 12 minus 15 will be 3. And since we are finding the absolute value, so it will be 3. Is 3 greater than the absolute value of the value at the RHS index, which is 18, minus 15, which is 3. Okay, this means we are checking, is 3 greater than 3? Of course it is not. I hope you understood the calculation. Initially we calculated the absolute value of 12 minus 15, which is 3, and then we calculated 18 minus 15, which is once again 3. So in both cases, the result was 3. So this means our last condition was not satisfied. Hence, we move the LHS pointer towards the left by one position. So what does this mean? So this means since LHS is now pointing at the index 2, it will shift towards the left by one position and now it will point towards the index 1. So let's have a look at that. And there we go. As you can see, LHS now points at the first index. And as soon as we do that, we have to ensure that the value of k is reduced by 1. This means the value of k now becomes 2. We again move on to the next iteration and yet again we check is LHS less than 0? No, it isn't. Then we check is RHS less than len? Yes, it is, since 4 is less than 5. We also have to ensure the next condition is true. So I hope the calculations are clear now. So is 10 minus 15 greater than 18 minus 15? That means is 5 greater than 3 in this case. Let me repeat that. I found the absolute value of 10 minus 15, which is 5. And then I found the absolute value of 18 minus 15, which is 3. And is 5 greater than 3? Yes, it is. This means our condition is true. So what's our next step? We simply have to shift RHS towards the right by one position. So this means RHS is pointing at the fourth index and now we have to shift it towards the right by one index. So it will now point to the index 5. Simultaneously, we have to ensure that the value of k is reduced by 1. This means k now becomes 1. We are now into our last iteration and we once again check is LHS less than 0? No, it isn't. But we then again have to ensure if the next two conditions are false in order to shift LHS. So we check is RHS less than the length of the array? Yes, it is, because RHS is now pointing to 5 and the length of the array is 6. And let's do the calculation. Is 10 minus 15 greater than 20 minus 15? That means is 5 greater than 5? Of course it isn't. 5 is equal to 5. So this means that our conditions are false. So what's our next step? We are simply going to shift LHS pointer towards the left by one position. Hence, LHS is now pointing to 1. It will now move towards the left and point to the 0th index. And we also have to ensure that we reduce the value of k by 1. So now k becomes 0. So this means we have come to the end of our while loop, or we have come to the end of our iteration. As you can see that the value of k is no longer greater than 0. So this means we have reached our output, and our output is simply given by the values that lie between the pointers LHS and RHS, which happens to be 10, 12, 15, and 18 in this case. Now that we know how the algorithm works, let us have a quick look at the code. So this is the function that will help us to find the insertion point. As you can see, we have the start and end pointers, and initially start points at the 0th index, while end points at the last index of the given array. Now we move inside our while loop and we continue our iteration until start is less than or equal to end. Inside our while loop, we calculate the value of mid and then we check if the value at the mid index is less than x. If so, start is made to point at the index given by mid plus 1. However, if the value at the mid index is greater than x, then end is made to point at the index given by mid minus 1. And then we finally have the condition where the value at the mid index is equal to x. In that case, we simply return mid. Now, a point to be noted here is if we do not return mid, then in that case, we are going to return the value pointed by the start pointer itself. Now you'll get to know why we are doing this when we run the test cases. So kindly hold your horses until then. So at this point, let's consider that we have found our insertion point, which is given by mid. And now let's find the k closest neighbors. To do that, let's use another function. And I'm going to name the function k underscore close. Now this depends on you. You can give it any name. This function retrieves the value that was returned by our binary function, that is the value of mid. And now within our k underscore close function, we will again have couple of pointers, LHS and RHS. I hope you remember how we initialized LHS and RHS. So RHS was pointing to the index of the insertion point, that is mid, while LHS was pointing to the index which was just before mid. And then we move inside our while loop and we iterate until k is greater than 0. Within this loop, we check our conditions. So as you can see, we have our conditions as we explained previously. I hope I do not have to explain them once again because I went through this again and again while I was explaining how the algorithm works. So if this condition evaluates to true, we ensure that the RHS pointer will shift towards the right by one position. And if this condition is false, then we ensure that LHS pointer is shifted towards the left by one position. Also, at the end of each iteration, we have to reduce the value of k by 1 such that when k becomes 0, we come out of the loop and then we return the output which lies within the index given by LHS plus 1 and RHS. Okay, so that was the code. It's now time to go ahead and check if our code works by executing the test cases on our code. So this was our first test case. So let's execute our program. And there we go. That's the exact output that we wanted. Now, before executing the next test case, let's understand why we need to return start if we do not return mid. Now, in this test case, the value of x, which is 15, is already present within the given array. However, if x is not present in this array, in that case, within the binary function, the value at the mid index will never be equal to the value of x. This is because the given array will never have the value x. I hope you get the point. In this case, 15 was already present in our array. So we reached a situation where the value at the mid index was equal to the value of x and thus we returned mid. However, when this does not happen, we keep iterating until start is less than or equal to end. As soon as start is greater than end, we immediately come out of the loop and then we return start or the index pointed by start. This means in that case, the insertion point will be given by start. Thus, we are returning the index that is pointed by the start pointer. So let's have a look at that. In order to do that, let's use our next test case wherein the value of x is not present in the given array. So there we go. And now as you can see, that 7 is not a part of this array. So let's execute our code and let's check if this works. As expected, we have the correct output. Let's also go ahead and check the other scenarios. Now in this case, the value of x is 4 and the closest possible values are 3 and 5. And we only need one neighbor or one number that is closest to 4. So the expected output is 3 in this case. And then we again had another scenario where we had only one integer within the given array. Now let's go ahead and execute both these test cases on our code. And there we go. We have received exact outputs that we expected. Okay, so we have successfully designed our algorithm to reach the final output. Let's do a quick analysis or a quick runtime analysis of this code in order to understand its efficiency. Since we are using the binary search algorithm, hence the complexity of this function, that is the binary function, is going to be log n, where n represents the number of elements in the array. Now, if you have solved binary search problems previously, then you might be knowing that log n is the time complexity for the binary search algorithm. And now talking about the k underscore close function, we find that we have to undergo k iterations. So this means the complexity of this function is going to be k. Hence, when we compute the time complexity of the entire program, it is going to be log n, which is the time complexity of the binary function, plus k, which is the time complexity of our k underscore close function. Now, this complexity is not at all bad. So you can definitely use this code and you will have no issues in your interview. However, in order to get an edge over others, you should always think of writing the optimal code. In this code, we have performed a lot of extra work where we performed the binary search for the whole array inside one method, and then we used another method for computing the k closest numbers to the given value x. Now, is there a better way such that we can merge both the functions and design an algorithm which is better in terms of space as well as time complexity? Yes, we do have another method which will help us to improve upon this algorithm. Now remember, even that algorithm is an implementation of binary search, and you can just say that it is an extension of this program. Here we have broken the entire process in two parts. But now what we will do is we are going to combine both these functions and create a better function in terms of efficiency. So please join me in the next part of this lecture where we are going to have a look at the optimal solution. That's all for this half of the lecture. Thank you.